Up here you have a relatively straightforward linear modelling problem. I want you to have a go at the first 3 questions there. So you're going to have to make some decisions as you go along, and how you make those decisions might affect. I am handing out a piece of graph paper to you with some scaled axes, because I want you to draw the most accurate sketch that you can. I should really just call it a graph. So an auditorium, place where plays might be held or speeches or whatever else. 14 seats in the front row, front of the stage. 18 seats in the next row, 22 seats in the next row, etc. So it's going to have a kind of a trapezium type shape, right? Question 1 is, how many seats are in the 50th row? That's the first question and the only question I want you to answer. So if you look at the instructions now, so I'm ignoring those other 2 dot points. Number 1, model the number of seats versus the number of rows. That is y versus x as a linear function. There's a hint there. You don't have to use n. In fact, I wouldn't be using n. I'll be using x and y. So the y coordinate of the graph is going to give you how many seats are in that row. Okay? Not the total number of seats, but how many seats are in that row. So when x equals 49, that would be the number of seats found in the 50th row, if that makes sense. Okay, see how you go, and then you should be able to do number 2 and number 3. If you've modelled it correctly, I don't have the graph here, but I do have the equation, then you would have, let x be the row number, then you would have, I hope, y is equal to 2x plus 14, and the first row is x equal to 0. Yeah? So the y-intercept with the y-intercept would be row 0. The y-intercept, so it should be cutting through at 14. Nope, you did not do that properly. Nope. 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 Lots of knobs. Nope. Nope. Purple, yes. Blue, no. Yeah, yes, I think so. Yes. So if it makes you feel better, I think that was 8 no's and 2 yeses. So if maths was a democracy, starting your y-intercept at 10 would be correct. But unfortunately, maths is not a democracy, which means just the front of the room here is correct, which means that, because correlation equals causation, if you want to get better marks, you should sit closer to the front. I'm sure that's how it works. Okay. And I'm not trying to suggest for you two that you got it really wrong. You got it as wrong as anyone else. So it should be like that. I can only draw a rough sketch, right? Because I don't have the graph paper here. So it would look basically like this, right? 14 for row. So at row 0, there's going to be 14 seats because we were told in the problem there, unless I got it wrong. That'd be awkward. I'm pretty sure I wrote down there are 14 seats in the first row, and that is row 0. And then it will go up like that. It's not my fault. I'll tell you why it's not my fault. Because I specifically said and wrote on that screen to treat the first row as row 0. So if you did from if you had your y-intercept as 12, then you could be forgiven for that misunderstanding, I think, although it's still a literacy and auditory fail, right? But it's a thinking success in that you've made sure that x equals 1 is 14. But I saw a bunch of people who had the y-intercept as 10, unless I just couldn't see it properly, and you did have 12 because it's a very small scale. Okay, so I shouldn't say forgiven, that's not the right language. It's understandable if you wrote 12, but it means that you weren't paying attention. So when we go for the 50th row, we would have y equals 2x plus 14. And then the 50th row would be y equals 2 multiplied by 49 plus 14. 2 lots of 50 is 100, so 2 lots of 49 is 98. Take 2 from the 14 to make it, that's 112. Is that okay? So, i.e., 112 seats in the 50th row. Now, I'm giving you a hard time for going to 12 on your graph and all that kind of stuff, and that's all entirely justified. But of course, I deliberately didn't make it easy for you by modeling a linear problem like I did, because I think you'd agree that we've kind of got the reverse of what we started with, if you remember, when I made the jump from arithmetic sequences to linear equation modeling, and that is now the shoe's on the other foot, right? Contextually, it makes more sense to use an arithmetic sequence where u sub 1 would be 14, the first row. But that's not how I modeled it initially, Iris. Oh, I don't think so, but I could be wrong. No, that's okay. That's my mistake. It still doesn't forgive your. Oh, it explains the 10. Right, I did see 10. I just thought I wasn't seeing properly. But it would. That explains the 10. Yeah, it is 4. My bad. It explains the 10, but it's still wrong. I'm wrong in that I wrote 2x plus 14 when it should be 4x plus 14. That's on me, absolutely. But it's still, your graph is still wrong. Sorry? Sure can. So you got 4x plus 14. So the graph is, it's still, like I said, that the sketch of my graph is still best with a 14 as the y-intercept. But now I've got to go for 4 times 49, which is going to be, 196 plus 14, 210? No, that can't be right. Is this? Okay, 210 seats in the 50th row. Okay, sorry about that mistake. Thank you, Iris, for picking it up. So apart from that, the rest of what I said stands. The y-intercept should always stand for the initial value. The auditorium does not have 12 seats in it anywhere, right? So making the y-intercept 10 does not make sense contextually. Either you start the graph at 14 and have a gap up before the x-axis. I mean, if we're going to use that logic, why did you stop at 10, guys? Why didn't you go all the way down to here? Why don't we talk about zero seats and a negative, can't think of what it would be, negative 3.5 row or something like that. None of that makes sense, right? So contextually, starting at 10 doesn't actually make sense contextually. Okay, so we have to start off with n equals 0 being 14. That's our initial value, our first value. And then we have to then say that the 49th row would be, so the 50th row would be when x equals 49. Does that make sense? I'm not just giving you a hard time. Well, I'm giving you a hard time to break open that these concepts are important, because I know the mathematics is not that hard, but the concepts behind them can be. Okay, anyone want to argue with me? You're welcome to. Every time I have an argument, we clarify things. No, arguments normally start with the word but. Like, you butthead. No, that's not a proper argument. Okay, next thing. What I said to you, what I said after that was that the problem is that the linear modeling doesn't really do a great job of modeling the scenario. In this instance, if I hadn't given you any indicators at all, if I'd just given you the auditorium problem without and saying work out how many there are in the 50th row, I would hope that some of you might be tempted to do it as an arithmetic sequence. And if you did it as an arithmetic sequence, it works out a little bit more tidier, right? We would have, there's an arithmetic sequence. We would have u sub 1 is equal to 14. That makes sense. The first row is 14. We would have d is equal to, I'll get it right this time, 4. That's good. That makes sense. It's going up by 4 each time. It's not negative 4. So therefore, u sub n is equal to 14 plus n minus 1 times 4. 14 plus 4n minus 4. So u sub n is equal to 10 plus 4n. There's that 10. Sorry? That's what you did? Oh, well done. After you did the linear function modeling as per instructions, you just decided to skip the linear modeling. So that's a literacy and auditory fail for you too. So then you'd be going u sub 50, which is equal to 10 plus 4 times 50, which is equal to 210. And it all feels right. And that's, Maddie, why I guess you chose to do it that way, because it felt like a better fit for the problem to do it as an arithmetic sequence. So top marks for thinking, not so much on the auditory processing, because I wanted to make some more links on that. Moving back to that sheet, I've got a couple of extra questions here. I don't want you to touch arithmetic sequences. Oh, actually, it's just one question. The third question is... No, the second question, sorry. The second question is, if there are 50 rows in the auditorium, how many seats are there? Look at your function. I'll give you... Look, if you can't do it in 10 seconds, you're not going to do it. I'll give you 10 seconds to use your function, Maddie. Use your function, which is y equals 4x plus 4t, to answer that second question. There are 50 rows in the auditorium. How many seats are there? Go. Stop. Who got an answer? Who got an answer using the function that you were given? Using the function that you were given. Absolutely fascinated to how you do it, because the answer to what's the problem with using the function to answer the second thing is that the function is not complete. By itself, it cannot give you the answer. So Iris, tell me how you did it just using your function. Okay, so auditory fail again. I think, Eve, you had your hand up. Mm-hmm. That's the number of seats. Whereas I've said, how many seats are there in 50 rows? So that's a literacy fail. By the way, I often say this in my classes. In this class, I hope this is true for everybody here. We're not afraid to use the F word. The F word being fail. We're okay to say the word fail. Okay? It's okay to use that word. A failure is just an understanding we haven't quite got there yet. But we'll get there. We shouldn't be afraid to say, oh, failed on that one. What do I need to do to get there? It's all part of the learning journey. So it could be an auditory fail, could be a literacy fail, it could be an understanding fail. It doesn't matter. If you can't identify where you're failing, how can you identify success then? So you have to work out the total number of seats there are in the auditorium. Total number of seats. So using the function doesn't get us there by itself. Of course, there are methods that you can use, but using the function, it's not fit for purpose, right? And that's the point I wanted to make. It's not fit for purpose. So I want to return to this little baby, my slideshow. And do you remember when we were adding up the series of numbers in that slideshow, like way back a few weeks ago now, we worked out that you basically take the number of numbers, in this case 50, and we add the first and the last, and we divide the whole thing by 2. Does that ring a bell? We explained why at the time. I'm not going to go back to the explanation, but that was kind of what we did. Well, that's what we've got, right? If I look at this question from that perspective, then what I need to do is I need to go, well, correct me on my numbers if I get them wrong. There are 14 in the first row, and then there are 18 in the second row, and then there are 22 in the third row, and then all the way up to, was it 210? And that's the first row, and that's the 50th row. From our linear function, we can get all those numbers out. We can go let x equal x equals 0. We get 14. Let x equal 2. We get 18. We can do that 50 times over. But oh my gosh, how tough is that? Instead, we can say arithmetic sequences give us a way forward. Okay, and Iris, I'm guessing that may be what you did to get your number. Yeah, so we can say that the sum is going to be 14 plus 210 multiplied by 50, because there were 50 numbers, divided by 2. Okay, so that will give me 50 multiplied by 224 divided by 2. Honestly, I can't do that in my head. What'd you get? 5,600 seats. I assume that's right. Is that okay with everybody? So it's an example of where sequences are better than linear modelling. So there are 5,600 seats in the auditorium. Okay. Just having a look at this. Yeah, cool. Making sure that my numbers are right here. In terms of giving a little bit of structured language to it, what we can say is that the sum or the series to n terms is worked out by multiplying n by the first term plus the last term divided by 2. That's a bit shaky, so I'm going to go one more line down, and I'm going to put the divided by 2 first. I can do that without any problems. N on 2 outside of u sub 1 plus u sub n, and that would give me the series. And it's a nice, neat little formula instead of having to deal with the numbers themselves. We okay with that? What have I got? I've got 5 minutes, so I want to just really tick off 2 things, and then that'll do for today. We don't always have the last term, right? We can always figure it out, but we don't always have the last term. We might be given a sequence of numbers like 3, 5, 7. We know the first term is 3. We know the fifth term. Sorry, the difference is 2. We don't have the last term. We might just be told to add up the first 100 numbers. Well, you can work out un and then substitute it in. That will always work. But there is another form of that series formula which sort of takes out that sort of step in a way, or it hides it a bit. So watch what I do. You only have to know the formula, right? And the formula is on your formula sheet. But I like to unpack things for people because I think it helps make sense. So S sub n, sorry, I won't start with that. Remember that U sub n is equal to U sub 1 plus n minus 1 times d. Does that ring a bell? Remember that? Okay. Remember, these two things are synonymous. U sub n is exactly equal to this value here. This value here is exactly equal to that there. So in our formula, we can take the U sub n and we can replace it with that thing I had there. U sub 1 plus n minus 1 n, oh my gosh, plus n minus 1 times d. So what I've done now, I've literally replaced U sub n with what U sub n is. Now, if I look at that left-hand side there, those square brackets are not needed. I just put them in there so you could see. So I'm going to get rid of them. Can you see what's happening here? That means I can go n over 2 outside of 2 U sub 1, U sub 1 plus U sub 1, plus n minus 1 times d. Often, because extra brackets upset people sometimes, I've seen the formula, I can't remember what it is like on the formula sheet, use these things called braces. And so you might see it written like this. Okay, next lesson, I'm going to show you how to use this series formula to solve problems, and there'll be plenty of practice time around that. There's one last thing I want to show you. So if you could, if am I okay? Is everyone caught up okay? Alrighty. So I want to return back to your graph now. Have a look at the graph. And what I want you to do is I want you to draw in, different color if you can, a perpendicular line that goes all the way down here like so. Just conscious of time. Okay. Even if you haven't quite done that yet, have a look at the screen here. I'm tracing around the outside of the shape that is created by the line, by the y-axis, the x-axis, and the line I just got you to fill in there. See that? I'm filling it out. It's a bit like a tail fin. What shape is that? Someone's called out, but I don't know what you said. Yeah, well done. It's trapezium. Trapeziums can have a straight edge like that. That's fine. So these are the two sides that are not parallel, and these are the two sides that are parallel. So the formula for a trapezium is area is equal to a half A plus B multiplied by H. That's the area of a formula. In your trapezium that you've created, A is like that distance there, B is that distance there, and H is this distance here because it's right angled. What I want you to do between now and tomorrow is I want you to work out the area of that trapezium. Work out the area of the trapezium. That might sound like a mysterious thing to do, but I've got a good reason for it.